So let us try and fix this code by going to Python Tutor. So here we are in Python Tutor. We're going to edit this code to actually try and return a floating point value. We don't want to do integer division over here. And the way we can tell C that we want to do floating point division at this point, not integer division, is by making one of these, or perhaps both of these, floats instead of integers. Let me show you a couple of ways in which we could do this. Firstly, this 1, if you just write 1, it's an integer. On the other hand, if you write 1.0f, then that is a float. If you just write 1.0, that is a different type of float, which in C is called a double. Now here is another confusing difference between C and Python. Python's float corresponds to C's double, and C's float is like a less precise version of Python's float. So first, let us try and fix this immediate error, which is caused by integer division. I'm just going to change this to 1.0f, and let us try and see what's going to happen now. This expression is now a mixed expression, meaning its numerator is a floating point value and its denominator is an integer. When C encounters this kind of a mixed expression, it tries to equalize the two types of values. In this case, it will do that by actually promoting this integer n into a float, and as a result we will do floating point division. Let us first see how this works. We click on Visualize Execution, and again we start at main, we initialize n to 1001, we call our inverse function. This value gets copied over to the inverse function's n, and now we check this if condition. Now we have a proper test for equality, so of course n is not 0, we skip past it, and now we do 1.0 float divided by integer n. Python Tutor doesn't show us the internal steps involved, but this will promote the n from an int to a float, and it will calculate the resulting division using floating point division. But we don't actually see that value visualized in Python Tutor as a return value. Fortunately, that value is going to get printed over here, and we get this answer. Now pay close attention to the numbers here. These digits do not look familiar. If you go back to our lecture slides, you will see that this is not what Python produced. And if you actually calculate the answer by hand, you will see that this is incorrect. This error is happening because C's float type is less precise and it is producing an error. Before we fix this error, let me quickly show you the other way in which we could have modified line 8 to do the correct type of division, and then we will actually fix this error to produce the same answer as Python. So I'll click on Edit this code, and as we have said, if we leave this division like so, this is integer division and it will produce the wrong answer. So one way to fix it is to promote the numerator to a float. The other way is to promote the denominator to a float. Now this is a little bit more complicated, but here's what it looks like. So firstly, for simplicity, I'm going to put this in parentheses, just so that it is clear that there is a single expression in the denominator. Now if this was Python, we would do this as follows. We can convert this n into a float by just simply saying float of n. as if we're calling a function named float. We have seen that float is not actually a function, it's a built-in type, but you can actually call it as if it were a function. The syntax in C is not quite this, but it is similar to this. So we take our n, which is an integer, and we tell C, I would like you to treat it as if it were a float, and the way we do that is we put the word float in brackets. This kind of an expression in C is called typecasting. We are telling C that I wish you to cast this integer into a float, as if I was performing some sort of a magic spell. So I am saying to C, convert or cast this integer into this type, which is a float. And now in this expression, I have a numerator, which is an int, a denominator, which is now a float. Since that is a mixed expression, C will further promote the numerator into a float and then perform the floating point calculation. So once again, if you visualize this code, this will produce the same incorrect answer as before. We'll cheat by clicking on last so that we don't have to see all the steps, and observe once again that we have this loss in precision. So let us try and fix this issue now. We'll click on edit this code, and we will tell C, please don't return a low precision float. Please use the higher precision double, which is the same as Python's float. And now don't do this calculation this way. One option is convert n into a double, and then that will do the calculation similarly, but this time using double precision instead of regular floating point or single precision. Or the way we did it earlier, we do 1 by n, which won't work, but we make the 1 into a double. And if we just write 1.0, by default, this is double. Now, before we run this code, one other small thing that is worth changing is in this printf statement. Here we used this syntax to tell C to expect a float. But now this inverse function is returning a double. So it's better to tell C to expect a double here. In C, the way we say float is f, so you would think the way we say double is d, but don't forget %d is already reserved for the decimal representation of integers. So the way we write this is with %lf, which is long float. Now this is a bit unfortunate because this L probably looks like a 1 to you, and you might think I'm printing a float to 181 digits of precision. I'm not. I'm printing a long float, namely a double, to 18 digits of precision. Let's execute this code and confirm that it works as we expect. Once again, I will just click on last so that we can see that we now get the same answer as our original Python code. So to summarize, the way we translated that simple Python program into C was to recognize a few important differences. Firstly, the C version of the function cannot return a float because in C, float means single precision. If we want to mimic the precision of the Python code, we have to use double. Of course, we fixed this error, and we avoided doing integer division, this time by using a double precision numerator. Now, when I took this screenshot, notice I forgot to change this to %lf. It is better to use the correct specifier, the correct format specifier, otherwise sometimes you can get slightly different looking results. So this is an unintentional bug that I have accidentally introduced. You should fix it.